Hello everyone, this is Arduino Maker Lab. Do you want to be Iron Man too? Let's get started.
The cannon moves in sync with the direction of your arm. Features 2 degrees of freedom. Pull your hand back quickly to fire the laser weapon. Wave your hand side to side if you want to spare them. You're probably wondering what this does. I use it to battle Godzilla. See, Godzilla's been chased off by me. Of course, if you'd like. Alright, let's get back on track. Let's take a look at how to build this watch section. Step 1. 3D print a watch. Files are on my GitHub. Step 2. Prepare an ESP32C3 board, an ICM20948 module for jumper wires, and one piece of Velcro. Let's start wiring. Connect the IMU module's VC to the ESP's 3.3 volts and GND to the ESP's GND. Connect SDA to IO3 and CCL to IO2. Use hot glue to secure the circuit board. Tuck the wires into the watch compartment. Prepare a 5 volts output battery. Made in China. Oh, it's inserted backwards. Use hot glue to secure the battery. The watch section is complete. Secure it with 20 mm wide Velcro. Let's see what we need to build the cannon. An ESP32S3 board, a breadboard, a 3D printed cannon, and a laser module, as well as an SG90 pan tilt kit, which you can buy on Amazon, like this. First, glue our pan tilt module onto the breadboard. Here I've already glued the pan tilt and the cannon together. Next, glue the laser module onto the cannon. Let's start wiring the cannon. Connect the positive pole of the laser to the 5 volts power supply. and the negative pole to IO17. The pitch servo for tilting up and down is powered by 5 volts, and its signal pin is connected to IO16. The yaw servo horizontal direction is powered by 5 volts, and its signal pin is connected to IO15. All 5 volts power comes from the USB input. I shorted the 5 volts input or output pads of the ESP32S3 so that the 5 volts from the battery will also be connected to the 5-VIN pin. The wiring is complete. Glue the wires to the breadboard. Use the same type of battery. Stick it onto the top of the ESP module. If you find your laser module isn't bright enough, you can adjust the value of the current limiting resistor. When powered by 5 volts, it's recommended not to use a resistance lower than 150 ohms. The offset angles and inversion settings for the 2 servos are defined here. Since my pitch servo is installed in reverse, I have enabled pitch inversion here. The 2 ESP devices use ESP-NOW technology, so the watch end needs to know the MAC address of the Canon end. The Canon will print its own MAC address every time it starts up. Fill in the MAC address of the Canon into this position on the watch. I have provided source files and G-code for all mechanical designs, and you can modify them according to your own needs. An open-source Ironman Palm model is provided here, which you can print, assemble, and use on your own. All materials are open-sourced on my GitHub. By the way, remember to perform a calibration each time you power on the watch. Just rotate it 360 degrees around the X, Y, and Z axes. See you next time.